So I was saying, would you say Elon Musk is a scientist or an engineer? I'm not sure it's both. Yeah. So what did Elon Musk do, basically? He created Tesla cars, SpaceX rockets. What else? Okay, I'm sending a poll on Zoom. So what did he do? He created SpaceX, which is basically rockets, low cost. So he combined cheap elements and built a rocket with cheap elements, basically. He built, well, he commercialized Tesla. He has a company called Neuralink to read your mind directly, and what else? He has another company called OpenAI, which tries to see the limits of AI to see if it's dangerous or not. Wow, wonderful. So yeah, so I see somebody thinks he's a scientist. So these people, who are you, and can you explain why? And the Boring Company, very good, Raven. So the Boring Company, there is a lot of science in the Boring Company. I agree. Tesla has a lot of patents, right? So if you go to Tesla patent, it has a lot of patents. But if you look at his work, most of it is technology. And he look at the purpose of his company. The purpose is not to understand nature. As he said, the purpose is to, with Tesla, is to improve the world by reducing CO2 emissions through electric cars, because he thinks that we're in a very dangerous situation when there is too much CO2 pollution that might kill us all. And that is his purpose. That to me looks like trying to improve humanity. Therefore, it really fits with the description of engineering, right? Yes, the name is quite fun, set of things. And the same with the other companies. SpaceX, the purpose of this company, if you read it, is to have humans on Mars, right? And so that we become a multi-planetary species. So he's not interested in going to Mars to see what's on Mars and understanding Mars. He's interested in expanding humans to Mars. Does that make sense? So he may be a very bright person, but he's not a scientist. For example, he doesn't write papers, science papers. No? So he writes other things. Tweets. Sounds good. So people that still believe, yes, so the purpose is different. They might do similar things, but the purpose, that's what matters. Now, people who say Elon Musk is a scientist, you still think he's a scientist? All right, good. Next one. And so here you have a very good definition here. So technology is the outcome of engineering. Sounds good. It's a very good definition, right? Here you have a definition for a engineering that we may use in the exam. And here you have other keywords. And here you have the types of engineers, right? So do you have Miro boards open? Yes, can we go to Miro boards? Welcome. Right, so I'm gonna write something here. So follow my mouse. So can you type, let's do brainstorming. Wait a second. Hold on. Hold on. Give me a second. Okay. Very good. Okay, so can you brainstorm here different types of engineering that you may know? So I know electrical engineering, but there's other ones. So can you type different ones? What types do you know? Now you can modify the post-its. Ahmed, very good. Tell me on Miro. Maybe I share the link here so you can take it. Hold on. Can somebody share the link? Here it is. We see everybody coming. Okay. So what kinds of engineering do you know? So pick up a post-it and modify it. And change the color after you modify it. Computer engineering, very good. So what we got. And excellent. Oh, requirements engineer. What is that, Muna? Can you explain to us?
We studied it, Mr. in software, introduction to software. I forgot the name of the course, but before you design something, you write requirements. It is, we studied it in a course. And it's the first thing that popped in my head about engineering.
Excellent. Okay, I didn't know there was a engineer called requirements engineer. Okay, interesting. Industrial, aerospace. Anybody wants to explain another one? Aerospace, aircraft, electrical. Excellent. Okay, nanotechnology. Wow. Excellent. Okay, so let's go back to the slides. So yes, you have the typical engineering. When people say engineering, people usually think about mechanical, right? So these are people that deal with robots, machines, cars, right? Most of the people working in car factories, mechanical engineer, energy engineers are usually mechanical or industrial, air and space, both, right? So this is the kind of products or output their work does, right? Systems, you can have a systems engineering, so work with systems of things. Robotics, for example, is an example of systems, people that work with systems. Then you have civil engineering, and this is the people that build things like bridges and also buildings. Then you have tunnels. Environmental is also a very growing area, so how to clean waste. Civil engineering, people working in systems. So what is that? So it's very popular in America to have a thing called transportation engineering, which deals with traffic, basically how to design roads so there is no traffic jams, or how to design a network of transportation. They have electrical engineering, which is maybe the most powerful engineering society in the world. So this comprises electrical engineers, comprise computer science engineers, electronics, and all this. These engineers are in a society called IEEE. Anybody knows this one? IEEE. So IEEE is the world's largest technical professional society, and well, most of the professors in the school are members of this. This society does many things. They organize conferences, they publish journals, they also have a student chapter. So if you become a member, there's a lot of benefits for you. They might they organize student events, summer camps, many things. IEEE also creates standards. Maybe if you look in the back of your electronic devices, like my iPhone or your Wi-Fi router, you will see sometimes IEEE mark somewhere. For example, this mark here. What is that? So that is the standard that this society has created. Yes, that we have created. So when this is a Wi-Fi standard, for example, so this is the kind of job this society does, and I recommend you join this society. It will help you find a job if you like it. Right, so this is the kind of output they do, radar engineering. These are some of the engineering majors that exist. A lot of them, right? Some are newer and hotter, and some are older and more not so hot, but still. Inside software engineering, you have a lot of subdivisions like database, because it has grown so much, right? So we will see that in other lectures. So what do engineers do? Well, so as we said before, they focus on products to improve society. And these are the 3, 4, 6, 7 areas or activities they do. They research, like scientists sometimes. They develop and they test. They design, they analyze, and they do systems work, which is to put things together like a Lego. And they build. So different kinds of engineering have more of one phase or more of one area than other ones, which is completely normal. And these are other things they do. They could do take care of a plant, for example, or do maintenance work. They can do sales. Do you agree that engineers can do sales? Do you think it's a typical job? Yes, no? Maybe? So, okay, I'm Steve Jobs, right? I never heard of a sales engineer, Munalali. Okay. Shall we do a poll? Because this is very interesting and important. Polling. End the poll. I'm going to send you another poll. Right. Very funny. Well, no poll. So listen to me, guys. Most of the engineers work as sales engineers. When there is a thing called sales engineering, there is also a thing called pre-sales engineer. Yes, it is true. So imagine Steve Jobs and he makes the iPhone and then he doesn't care how to sell it. So yeah, many engineers end up in sales, and usually as an engineer, you enter in technical support or technical jobs. And then as you grow up or you progress, you go towards sales. Because if you have a product, but there are no sales, there will be no jobs for no one in that company. Yes. So sales is a very, very normal and typical job for engineers. And it's true that some engineers don't like to do sales. Some do, but some don't. And that's very interesting. Consulting. Do you know what is consulting? So consulting is, yes. Can you give me advice in exchange of, can you give me an example of consulting? You can speak on the microphone. Do you know any consultant? I used to be a consultant when I was young. So consultants, they work for a company, but they solve somebody else's problems at a different place, at a different company. Typical consulting job. Imagine that you are a company, like imagine you are a bank, and you need to build a website for the bank because you don't have one, and you have to have a website. But you are into banking, you don't know anything about websites. So what do? You go to Accenture or any other consulting company, Capgemini, Ernst & Young, and you tell them, please build me a website. And Accenture says, okay, I will send Jose to you for 6 months to your office, and he will build a website for you there. And that's what the consultant does, right? Sounds good? Yes. So many engineers work as consultants as well. Management, same. Many engineers work as management. Do you know who is the CEO of Apple? It's Tim Cook. Well, he was an engineer. Yes. Great. So yes, engineers usually start in technical jobs and positions. And now, if you have an engineer in sales, he might do some engineering job, but mostly it's going to be sales. So that's not exactly engineering, but that's good. To be a good salesman, you need to know the product. So there's not the better person to do the job. Good. Great. Excellent. So that's wonderful. So that's the first overview of engineering and what's the difference, where it comes from, what it means, and the purpose. Sounds good? Good. And today's lecture is going to be about the difference between, so you have it here in, this is the slides we're going to see now, yeah? So the ones that say number 2. And you have here a document that is about Agile and Scrum that you can read later. And so I was saying, now we're going to see the difference between two very important engineering ways of working. And there are two main ways to do engineering work or to plan engineering work. One is called Waterfall and the other is called Agile. Right, so I'm going to go to Miro. Let's go back to Miro first. And I'm going to type here Waterfall. And here I'm going to type Agile. And who can define or explain in one post-it only what is the difference between Waterfall and Agile? What is the difference? Agile is simple, okay. What do you mean line versus circle? What does that mean? I'm more flexible, okay. Interesting, Muna, good. Muna, yes, good. Agile allows change while Waterfall does not. Yeah, good, good. So I take it that you know Agile a bit. Okay, so let's go back to the slides. Well done, everybody. Yeah, did I miss something? No, it's good. Wonderful. So let's go back to the slides. So today we talk a bit about All right, and before we go into Waterfall and Agile, so when we talk about engineering design and what is the process of engineering design, is you can take it as this: is a set of steps or a recipe to do a design, yes, about an engineering project. And this means to think how you will work. That's what engineering design means, to design the engineering process. And to design means to define, to create, to structure how you will attack a product. Not just the product, how it will be, look like, but how you will work. Does that make sense? And that's what we mean by engineering design, design engineering. And then you have flavors, different versions of this. And so when we're in software, for example, or engineering, we have this way of organizing this work, this planning work. One of them is Waterfall, the other is concurrent engineering, the other is spiral model, and the other is Agile methods. And so we will see them because you have to see them. Right, this is a typical steps in the typical design process. So first you recognize a need, then you define the problem, then you define the constraints. Then you have what we call the design loop, where you build something, you analyze, and then you make a decision and you iterate. And then you try to improve that design. So you do this a few times, and then you evaluate, and is it good enough? And then you show it. Even after you show it, you might want to build it, like in case of a bridge, for example, and they might want to check if the bridge can withstand enough weight and so on. And then there's not only delivering the bridge or the product, there's also follow-up, warranty, service maintenance, and so on, customer support, and so on. Yeah, so and so on. Yeah, so that's the universal template. But for example, a very popular one is what we call the waterfall model. So the waterfall model, which comes from 1900 to 100 years ago. You have this, you have requirements. So you want to build a bridge. So somebody tells you, yeah, we want to build a bridge. You should be able to withstand this load. And so many cars, and say, okay, or so many people, say, fine. And then you transform that requirement from the client into specification. Then you do the general design, then a design, then you build it, you test it, and you care for it. Yes, so this could work for software, a bridge, any big project, building a rocket, and so on. And so this is like explanation of each phase, and so on. So waterfall became a very popular method because there was nothing better before. So it was very useful to, if you have to build a ship or a bridge, it was really useful way to plan things, and so on. Right. The problem is that, as somebody said in Middleboard, who said this one, you work in a linear way. The problem is that what happens when you have defined the requirements, and this works for software as well. You did the specification, requirements, document, and then you do the design of the bridge, and then you build a bridge, and then you realize, or the customer comes back to you and say, oh, I want a bigger bridge. That software I told you, that those drawings, no, I want also to do, he wants a change. in Waterfall and think that this might take 2 years long, right? And so imagine you are 1 year in the project, so you start building the bridge and the customer wants some change. It's complicated. Right? The people that build the requirements maybe are not there anymore in the team. So this is a big problem of Waterfall, right? And what people realize in software is that software changes so much and so often that Waterfall is a very bad way to work building software. It's not very good because 1 year or 2 years in software is like decades in normal engineering, right? It's too long, things change too fast. And because there's so much uncertainty, and the reason there is uncertainty is that there's a lot of complexity, because when you build software, it's not just you and your Java building software. You depend on the Java virtual machine that depends on Oracle, and Oracle might update the Java virtual machine for the next release. And that means that what you thought was a very good way to do something, maybe in the new version is not, and that might change everything. And so it doesn't make sense. And because this complexity and this rapidly changing and this interdependency on many, many components that not just depend on you, Waterfall model doesn't work for software. It doesn't work very well. And the reason is that it's not very flexible to new changes. Does it make sense? Waterfall is beautiful. It doesn't mean it's a bad idea. And you can still build it and use it to build software or to plan a project, right? They have this concurrent engineering. So what people were doing here is like, I do the requirements and then I will finish it and then I will go to the next phase. And then somebody came and say, well, wait, you can do a few things in parallel, right? To make the thing shorter, right? And so concurrent engineering came, and that's what we now know as a Gantt chart. Yes. So a lot of engineering work is they want to make this as short as possible and to find what we call the critical path. And the critical path is the longest time it will take, the shortest time it will take to finish a project, right? I assume you have seen a thing called Gantt chart. Have you seen that? Yes. Yes, good, excellent. But are you familiar with it? Yeah. They have the spiral model where you you go into a continuous loop of design, coding, testing, and changing the specifications as you evolve the product. And so you can understand Agile as something like that, similar to this, where you go in a loop. And so we'll see that. There's also a thing called extreme programming, which was quite popular a few years ago, now not so much. And so this is a very, very good table that usually is in the exam. And so look at this here. So Agile methods would be, so we'll go into Agile soon. And plan-driven methods like Waterfall would be on the right side. So if you look at the objective of both, so the primary objective of Agile is what we call rapid development. And so when you are doing Agile, you're interested in going fast. And remember that this means cost when you're talking about software, because the main cost of software is payroll, so humans coding, the coders. In plan-driven methods, what we call like Waterfall, the primary objective is high quality. So if you build a bridge, you want to build one bridge that doesn't fall, right? And so that's the main thing. If you build a rocket, the same. If you build a tank, kind of the same, right? They have a by project size, so Agile only works with small teams, and we will see that later. Waterfall works with really large teams, so that's quite good. Then you have the workers you have in the team. So, well, obviously, Agile people that do Agile, they're team players. They have to be team players, and they usually work in knowledge economy. Whereas in Waterfall, you want workers that like to follow plans, and it's not necessarily knowledge workers. The project requirements, this is the main difference also, is that in Agile, the requirements change as you develop the app. And that means that at the beginning, the customer wants to do something, but as you build the app, the customer will want to change things, because at the beginning, he didn't even know what he wanted. This is a very typical thing. So it's very normal for an Agile project to change the requirements a lot from the initial requirements. So it's like a learning process. In plan-driven methods, this is very unusual. Like when you decide the shape of the bridge, you usually do not change that unless there's a very important reason. Yes. So good. So this is basically a summary of this. Sounds good? Any questions about Waterfall? Anybody has some input and so on?
Mr.
Yes.
I am
Yes. Muna, say yes.
I don't know what's really the difference between spiral and agile. I feel like they're like very close to each other.
It's not. There's no difference. It's like spiral methods is like a big group. You can think of it. A spiral here means iteration, or sorry. There's this thing called the spiral, and we will see that again later. So you can use a working method called spiral model of working. You can consider Agile as a part of the spiral thinking. Sounds good? So nobody uses a spiral. There's nothing called spiral model in software. Like it's like a high level model. So don't worry about it. What you will use is Agile, which is a kind of a spiral. So it's like a generalization of Agile. Sounds good? Like you can consider Agile as that inside Agile is a spiral, which is quite the iteration. Yes. So don't worry that there's no questions about, there's no spiral way of working. Yes. Other questions? So for example, if I show you maybe that will help you. PDCA, for example, PDCA is a famous, the same idea of the spiral, right? So you plan something, you do it, check if it worked, and you act. So this is, you could consider PDCA model as a spiral as well. Yes? Do you know this PDCA, by the way? So PDCA is used at Toyota when they need to improve a car. Okay. You need to change something in the car, right? The problem is the car is very complex. So if you change something, you might create a problem somewhere else, right? So they didn't know this. So for example, it happened that they changed something somewhere and somebody changes something somewhere at the same time, and then they create a huge problem somewhere else, and then you have an accident. So they say, okay, everybody stop. We're gonna do this plan. So we're gonna change one thing. So we plan it, we change it, we do it, we check that everything else works, still works, and we then decide what's the next thing to do. And this hygiene helps them to reduce the chaos, because when you have a complex system like a car and you start changing things at the same time, you can have unexpected consequences. Because of that, they decide to separate the changing from the planning from the changing, from the checking if the change worked, which is basically improving things in the car. Sounds good? Don't worry, it's not part of the exam, but you could consider that as part of a spiral model way of working, right? The point here is that today, when you go to work, you will work with Agile, and this is what you will learn in this course. You will learn Agile. Unless you go to work for a military company building software for jet fighters, there they don't use Agile, they use Waterfall. But if you develop all the apps that you see in the App Store, they are developed using Agile methods. Most of the software built today is built using Agile methods. And if you know Agile, or you will find it's easier for you to find a job. If you don't know Agile and you graduate from computer science, but you don't know Agile, then nobody will take you seriously. Sounds good? Great, excellent. Okay, so we will stop here, and for the next class, I need you to install or create Jira. So Jira is this, and you have a free account with the university email. So please try to register at the website, Atlassian. So as you did with Trello, this is the same. Actually, Trello belongs to Atlassian. And with your university account, you have a free account. And how do you manage the Agile process? Excellent, perfect, Raven. You use Agile, Atlassian, and also Jira. And so if you know Jira, it will be very easy for you to find a good job. Sounds good? Questions? Right, good, excellent. So in the rest of the course, we will learn Agile, and we will do this by doing small projects. And you will use Miro, you will use Figma, and you will use Jira. And then I have a challenge for you. So I like to find an explanation video about Agile, and I like see if somebody can find some good, 5 minutes, 10 minutes introduction to Agile on YouTube maybe, or on Linda or LinkedIn Education. And so if you can share it on general in the next following days, that'd be really cool. I will give a bonus point to the best suggested video. Sounds good? Excellent. Right.
Mr. What we do again, we explain about Agile or Jira?
No, you don't have to. Maybe you know some very good explanation video about Agile on YouTube. So if you know it, you can share it on the general channel. Sounds good? You don't have to make any video. Yes, okay. You don't have to make any video. Yes. Right. Excellent. So for the next class, I will send instructions soon. And I don't know if it's going to be Zoom or not yet. Is anybody new here that is the first class? No? Okay. Good. So I think that's it for today. We are 43 people. I think we need to do some small attendance. So before we leave, you can ask me questions while I do the attendance. Let's see if I continue. Doctor, for my bonus, I'll talk to you in Slack. What bonus said? Oh, we're 46, okay, and we are 44. Okay, so who's missing? Do you know who's missing? No, you don't know who's missing. Yes, it's recorded. It's being recorded, the class. Okay, so let's see. Nasser, are you here? Nasser and Aisha, are you here?
Yes.
Okay, and Mohammed. Nasser, are you here? No.
Yes, I'm here, Doctor.
Oh, you're here. Sorry, I didn't see it. Oh, you can type it and then I'll look for it. Mohammed and Omar, you here?
Muhammad is here, Doctor.
Excellent. Modi, you're here. And Ali, you here? Ali? Suhail and Bryce.
I'm here, Doctor.
Excellent. So I see that Ali is not here. Is that correct? And what else? Asma and Salma, you here?
Yes.
Tari and Asma
Asma's here.
and Salma. Salma, calling Salma. Okay, so Salma, you're here.
Yeah.
Good, awesome. Ahmed and Walid. Ahmed, Walid. Walid, calling Walid. Walid, okay, so we only have two missing people. So that's it. And I'll see you next class. All right, you can leave. Have a good Agile morning. Yes, see you soon. The class is recorded. I will send you the link later. Awesome, good. Super exciting. Super, you too.
Doctor.
Yes.
Come on, I just went for the bathroom. 3 minutes, you take the attendance. What's my luck? I've been here all the lecture.
Okay, don't worry. You've been here all the lecture.
So, Doctor, you break my heart, صراحة.
Wait a second, I'll remove it. So what's the difference between technology and science?
A big difference, Doctor. Science, technology is mainly used to serve for human uses more than science. And also technology, usually people invent, and science like people you find in nature. And Elon Musk is an engineer, not scientist.
Why?
Why Elon Musk is an engineer, not scientist? Because he focuses about design more and
solving, because the purpose of the companies is to solve or improve humanity, right? Not to understand.
Like for human uses, like I said, for human uses. Not to understand the nature or...
Yeah, human benefit. Okay, you have convinced me.
See you, Doctor.
Good job. All right, so I'll see you next class. Have a good day, guys.
But Doctor, wait, did you make me 100%?
Yeah, you're present. Oh wait, yeah, you're present. It's only Ali who's not present.
I am Ali, doctor.
Ah, sorry. I thought you were.
Sir
Waleed.
Mood is here.
Yes, okay. خلاص, thank you, doctor.
I thought you were. Who's Mood? Moody. Yeah, you're here. Don't worry.
Thank you, doctor. Thank you.
See you. See you.